Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today I'm going to show you how I repaired this astrometer. Not sure how I damaged it. It wasn't during a test. It was a physical damage. Kind of hit the circuit board with something sharp. And I thought it was just knocked off a MELF resistor, but turned into a little bit more repair than I originally thought. So I'll show you what I did to repair this, okay? And yeah, it's just been sitting off the side. You know, I kind of put it off the side with all the parts and kept meaning to get to it, but I got so many projects that I'm trying to squeeze in that I just let it sit there. But I wanted to get it back on the bench. I wanted to clear out that area where I had this guy sitting. So took the time, got it working again, and did a video. So let's take a look at that, and I'll show you what I did. Oh, and give the video a thumbs up if you like the video. That helps YouTube analytics a lot. Now if you don't like my soldering or how I approach the thing, still give me a thumbs up for giving the old college a try, okay? Yeah, my soldering skills are a little rusty. Now I'm working on all these projects. They'll get better. Alright? Alright, thanks guys. So let's jump into this and I'll show you what I did. Alright, so in this little project, I have my little AstroAI WH5000A meter. Nice little 6,000 count meter, TRMS. And I did a review on this. I'll put the link down for that. Now, I don't remember what happened, but at some point, this was damaged. So I just set it aside to repair one day. And that's been months ago. So I've kind of forgotten how it happened, but if you look down right here, you'll see this scratch right across the board. I must have been trying to force something. I don't know how this became a victim of of some screwdriver or something, but if you notice, it just knocked off that resistor. Well, what was a resistor there? Okay, and that's this part right here. So this little resistor, you know, these MELF type resistors, or these little barrel type, this guy should be mounted right there. The good thing is it did it with enough force, it just knocked it right off, and luckily the resistor's large enough, the pads are large enough that it just kind of knocked it off, and doesn't seem to have damaged anything. We'll take the multimeter. I've already done this just to make sure the resistor is still good and worth keeping. But it's a 10K resistor and it still measures 10K. So still looks like a good resistor. Thing is though, if you look close, right here where this scratched across that trace, I got to make sure that trace hasn't been cut. Now when I look down with a 10X glass, it's hard to tell, but I don't think it is. And then it came across here and went across those two as well. So we need to ohm all of these connections to make sure they're still there, and then solder the part back on and put the thing back together. Alright, we're going to ask Mr. Fleur here to help us out. That meter is kind of on the other end of the spectrum as far as cost goes. Very nice meter. I'd put it up against the Fluke in the price range for sure. Okay, I'm going to hold it against this tweezer because it's metal and it's holding one end of it, and then that'll help me just touch this other end without letting it spin in the tweezers. Yeah, that's pretty darn close to 10K. Okay, so right here you can see it scratched all the way through here. See, I'm on continuity mode here. By the way, this Fleur comes with these like gold tipped leads. Yeah, you can see so it scratched deep enough to hit metal. Okay, now the resistor that this trace is going to, look at that, 4.9 mega ohm resistor. So it's a high value, high mega ohm resistor. So there's not much current, if any, going through that trace. All right, whoops, that meter's getting, I gotta prop it so the light doesn't glare on it. Okay, so you know what? I was looking at this trace, and if you follow it down, I was trying to find where I could touch it. There's these two vias here, so I want to make sure they're making contact, and they certainly are. So that's good. So I can come up to this end and touch resistor, see if that trace is still intact. And look at that. If I come down to that via, still making contact, but up here, nothing. I could put it in continuity mode so you can also hear it, but so when I come up here, it's not making connection. So it looks like I did actually cut that trace open. Well, hold on a sec. Here, if we touch, yep, look at that. Holy cow. So if I come back to the resistor, I could just solder bridge that, I think. Wow, holy smokes. Now the other thing you want to make sure is I didn't drag metal to this other field. No. And I could always just scratch that away in between the traces to make sure. So, alright, you know what? I'm going to scratch away a little middle there so I can make a solder bridge. Alright, I have this little dental tool. If you know a dentist, I used to actually know a dentist really well. Anyway, I'm just going to scratch away some of this, and then I'll clean that up on both sides. Make sure there's no metal dragged across that plastic right there. Alright, see if I got some alcohol, clean that up. Alright, so before I start soldering, let's check out those other traces. Now there's this trace right here, and I see a via here, and right here. Okay, that looks good, I think. Let's just measure some ohms here. Yeah, I think that's probably good. Let's try to measure another trace here, just to get an idea of how much copper they have on the board and what ohms we should be reading. Okay, I'll follow this trace right here. That's a very short trace. Okay. I think it's this guy. I think it's the third one in. Yeah, 0.5 ohms. Yeah, so this copper is probably only half an ounce, I'm guessing. And those traces might be, I don't know what they are, 8 mil. So, yeah. So there's some slight ohmage across several inches. So I think this trace up here looks good. There's also this really little trace right here off of this resistor, comes across here and goes to that pad right there. Okay, I've got connection there, but not to the resistor. Wow, looks like I must have cut through that one too. Alright, well, that little scratch did some damage, so I'm going to go ahead and try to scratch away some copper here so I can bridge that guy right there. And I think I'm going to hit this one too, just for the grins one there. I can feel a little divot in the copper right there, so yeah, I think that's going to need some little solder bridge there too. Alright, I think I got it. Alright, after taking a really close look at this area, you guys might have already spotted it, but this resistor that got popped off, there's actually a trace right there that goes over to this other resistor. So if I go there, and I'm going to go to the other side of this pad, and that's deep enough, that's a big pad, so that looks like it's going to be okay. Plus when I solder the resistor down, it should repair any damage, but that looks, anywhere I touch it seems to be pretty good connection. Alright guys, I found something else. See this ground plane here? This looks like a ground plane. All this via filled. I mean, it's pretty amazing. They've put a ton of vias into this ground plane and stitched it everywhere. And you can see it coming from here across here, kind of swarms all over here. But I went right across this, and there's that little gap right there. So if I come to this pin, I can touch it there, and I can hit it here. And then I scratched away some of this stuff over on this little pad right here, and there's nothing. Nothing right there either. So I think that little teeny little ground plane there that connected these two ground areas, now see it's connected here. It could be that this doesn't really mean anything, it's a shield. And so, but I may as well go ahead and reconnect that there anyway. Kind of crazy. Yeah, I'm just scratching away all this stuff so that I can put little solder bridges all over these places. And I'm going to solder here, put the pad resistor back on. So yeah, knocking off the resistor is just part of it. Now the ground thing I don't think is necessary to make it work, and the shielding, this kind of flooding is just sometimes, I don't know, when you have a shield, like a shield come down here, this little finger, I don't know about that. So, you know, if you're trying to shield something, then why not go all the way in? This should be stitched down to another ground layer. Either that, or it's just a flap. It's just flapping in the breeze. And when you have a real narrow connection like that to another ground connection, and if that's the only connection to this side, which it's not, we saw that it still connected to some of these other areas. So yeah, so anyway, it's just kind of a fill area, but I may as well reconnect it. So I'm going to go ahead and do that while I'm there. So I'm just taking a little bit of alcohol and just cleaning this up a little bit. Alright, sorry about the fan noise, just had to turn on my fume extractor. So I'm just putting a dab of solder on these little spots. That's a bunch of little vias there that's just sucking up solder. Alright, and I'm just going to put a little bit of flux on this. Putting a lot of flux on it. That'll just help pull the solder in and clean the joint. And just being careful not to bridge these traces. At least I'm trying. And I'm going to prepare these for the resistor. Okay. I'm going to try to put the resistor in there. Alright, so I put a big dab of solder on each lead. I'm not very good at this, as you can tell. I kept getting the tweezers stuck in between them after I tried to release. Alright, I think I got her in there. Okay, a little more alcohol. Try to clean up some of this extra flux I have in there. Alright. That looks pretty good, I think. Alrighty. Okay, now let's do the test and see if I've got a connection. Yep, that's good. Should be 10K on that side, that's good. Now this resistor. Let's go to either side of this. Alright, I don't know, you probably can't see that in the glare. Looks like my solder bridges are not very good bridges. So we're going to give that another shot. Okay, I want to see if this guy is making a connection now. Okay, it is there. Wow, that is enough of a gash that unless I put a gigantic blob there, doesn't want to bridge. Alright, I have to get serious about this. Got the little jumper wire and I put a little bit of solder on this. This is a lead that I've cut off some component, mounting it on a board. I kind of saved these just for this reason. Well, not for this reason actually, for test points, but it'll work for this. Okay, then once I have it in place, I'll just nip away the wire I don't need. And I've got some of these little guys with the little teeth like this that are really good for getting in tight places and doing this kind of stuff. As I say that, I can't do it. Oh, I soldered. Alright, so I'm going to solder this little wire right in here. Right the end of it, so I can just cut one end. Alright, whoops. Not enough solder. Okay, I'll just solder this wire right down on top of the broken joint. Alright guys, had technical difficulties here. Now what I did is that wire I ended up having to strap all the way down here around the corner because that trace, as I was trying to solder to it, it was just peeling off. So if I come to resistor now and come down to let's see, one of these vias. There we go. Yeah, that trace was so thin, and when I was trying to solder that piece of wire to it, it was just peeling off. And yeah, so kind of got frustrated with it, and then I forgot to turn the camera back on. So anyway, got that fixed. Okay, now I have this little piece of little teeny piece of wire left from that last section, and I'm just going to try to do the same thing on this one because I'm afraid it's just going to be a pain. Okay, let's see if that did that. Whoops. All right. Sorry. Brought the meter over. Okay. So this guy here, that little section there, doesn't look nice, but let me see. Should work right here. Oops. Okay. Yeah. So, wow. Now, I probably could have just put enough solder on there to make a solder blob, but it was kind of hard with the camera in my way and trying to do this on video and all that kind of stuff. So, it still looks like, yeah, it doesn't look so hot, but it looks like everything's making connections. It's been so long, I was going to put fuses in, put the power on, see if I get good readings, but it's been so long I forgot which fuse is which. This is a 10 amp. Yeah. The bottom one's the 10 amp. Okay. Alright, as I pop these in here, it just reminds me that they're captive. You know, captive ends. So if you drop it, it doesn't slide this way. But also, it's captured inside the plastic. But that's just nice touch. So I'm going to go ahead and put the battery in and check it out. Alright, I guess I'd have to go through an exhaustive test to make sure, but I mean, all the segments light up on the display. I'd have to go through all the ranges. I guess if I knew specifically what those parts were doing, those traces and that. But the temperature looks right. Yeah, everything looks okay. Alright guys, I think I'm going to get out my loop and take one more quick look and maybe take some more readings just to make sure. Yeah, this little meter on Amazon is just over $30. It's a 6,000 count meter, TRMS. Yeah, I've done a review on this. Like I say, I'll put the link below, but yeah, I'll just start using it and I'll report back if there's any problems, but I think all those connections are good now. They measure good, and I didn't see anything else damaged. Taking a close look through my loop. So there's this little piece up here that goes in the top. I guess that's meant for other options maybe. Then there's a strong magnet here. Comes with it. And runs on 9-volt battery. I'm going to put it all together and button it up. And then it has this little rubber boot that goes on it. So nice little soft silicone boot, I guess. I don't know what kind of plastic it is actually, but yeah, it's a pretty nice little meter. I'll get it back on the bench. Alright guys, so, you know, 6,000 count meter, TRMS. It's just over $30 on Amazon, I think, something like that, $30, $35. I think it's a pretty good deal. I mean, when I reviewed it, I liked it. It's got a lot of features on it, and, you know, it seemed to be a popular meter on Amazon, and so that's why I bought it. It's one of the first inexpensive meters to test and to show people, versus, so you don't have to feel like you have to spend, well, first of all, fluke, you know, money. If you want that kind of quality, you can buy FLIR for less, but or the amp probe. Amp probe and fluke are owned by the same people. The amp probe is really nice, and it's even less expensive than the FLIR. You know, there's some really cool features on the FLIR, but I really like this amp probe. But for money saving, this guy has seemed to be a really good meter. So, wanted to get back on the bench. Alright, hey, thanks to my patrons for all the support, and for the new patrons, it's awesome. You can become a patron for as low as $1 a month. Throw that out there. And thanks for everybody watching the videos. I got some stuff. I'm gonna try to put out another couple videos this weekend. Post this one first, and then right on the heels get some other videos out. So got it out of the way. Always feels good when you know, when you have one of those things that just sits there and stares at you, right? All right, hey, we'll see you next time, guys. Thanks.